Thank you for being there. I introduce a little bit myself. I'm Gabriele Baldoni. I'm working in EDLink. Company is mostly focusing, let's say, on hardware IoT, but I'm from the, let's say, the research office that is more focused on the software. And I will talk to you about Eclipse fog05. So before starting with Eclipse fog05, I think we have to start about the problem that is trying to solve. And then we will show how we try to solve this. So if you think today about hardware, about the hardware tires that you have in industrial IoT, in IoT, on MEC, you usually have these three. So you have the data center, which is mostly refers as the cloud, which can be private or public. Then you have some edge infrastructure that can be some, let's say, servers that you have in your factory or near your production plant, which is mostly is you, the owner of that infrastructure. While in the case, for instance, of MEC, the owner of that infrastructure is the telco operator. And then you have the things. For things, we mean something that has computational, networking, storage, or I/O capabilities that we may want to, let's say, to use it also as part of the IoT. Nowadays, when you deploy something in IoT or industrial IoT, you mostly use a cloud-centric perspective. So you have the cloud, you deploy your application on the cloud, and then this application will control, let's say, the things that are sensor or device that are very, very, let's say, low power devices with low resources. But this is good because let's say the cloud is operational convenient because everything is there. You don't need to bother about building your own infrastructure. You don't need to bother about writing complex software because you can use software coming from the cloud. And so usually you end up with something like this, in which you deploy your service, which is composed by, let's say, in the case of microservices with different components. And on the cloud, you run everything, the control, the analytics, the information virtualization, while on the device, and so on the things, you just rely acquisition and then digitalization and actuation. All the control information is on the cloud. But this is good for some use cases, but if you think about use cases inside the factory plant or like autonomous vehicle, maybe it's not the good solution because let's say, having the latency to the cloud is not compatible with the control loop that we have on the device. So you cannot afford this. Then people are start talking about a more, let's say, edge-centric perspective in which, okay, I have something on the cloud, this something on the cloud is working. I'm trying to put the same, let's say, abstraction and APIs and everything on the edge. Why? Because the edge is more similar to the cloud because at the end they are just servers, more or less. And so it's easy to control the edge with the cloud, let's say, infrastructure. And so this is mostly what's starting happening nowadays, in which also thanks to Kubernetes and other container technologies, you have your servers, you connect your server to the cloud management system, and then you manage everything through the cloud. But yes, we are just, let's say, putting the intelligence and the control more closer to the things, but we are still not leveraging the things, the computational capabilities, networking or I/O that we can have on that. So what is needed to do that? We think that what is missing and what we need is to have something that can abstract this, let's say, heterogeneous world and provide an homogeneous abstraction from the cloud to the edge devices directly to the things. So have something that can abstract the fact that you are dealing with a very, very heterogeneous infrastructure in sense of networking, computation capabilities, and so on, and exposing to the developers and to the user just a simplified API in order to manage all this. And this is why we came up with fog05. So the goal of fog05, as said, is to provide this abstraction. So it's abstraction in the sense that you need to manage this sort of, to provision and manage application in this heterogeneous infrastructure, in the heterogeneous in sense of compute, storage, communication, I/O, and not only that, also in the sense of application you want to deploy. Because if you think about the cloud, you usually have VMs or containers nowadays. But when you go through to, let's say, small devices like microcontrollers, in that case, you cannot think to deploy a container over there. You will things like deploying a native application that can run on that specific microcontroller, but you may want to be able to control that microcontroller directly using the same abstraction that you use for your cloud application. And so in order to that, fog05 provide a set of API and abstraction in order to have this unified view. And this also provide a decentralized way to manage this sort of devices. So let's see the architecture. fog05, let's say, is divided in two modules. The lower modules, which is the theme, is the fog infrastructure manager. So it's the one really providing this abstraction, and is the one that will deal with heterogeneity. So it is this layer that at the end has to provide some abstraction to the user and to the upper layer in order to have this unified view. While the upper layer, the fog orchestration engine, is just the one that should provide orchestration for your applications. And both the layers provide different abstraction and different APIs. So the force is not yet there. It's something we are working on, and we are in the design phase of this. As said, this layer should provide all the orchestration capabilities. And the only, let's say, abstraction that we define today is the entity, which is just a new fancy name for an application or a service. Why we changed the name? Because talking with customers or with people that, for instance, coming from telco, they said, okay, but this is a network service. But when you talk with people coming from, let's say, industrial IoT, they say, yes, but this is my application. So we came up, okay, we call it entity and we don't care. And for us, an entity is just a composition of, let's say, of FDU, and we see after what the FDU are, because are, let's say, an abstraction provided by the lower layer. We will define that later because it's something provided by this layer. So at the end, the entity is just a composition of view, but you can think as an FDU as a component of your application. So in the case, for instance, of if you think about microservice architecture, can be a container running some sort of service. And also this layer should, let's say, provide all the enforcement on the constraints that you define in the entity, the enforcement on the life cycle. So if I need two replicas of the same FDU, it has to provide all this sort of stuff. I say this part is not yet there. We are in the design phase of this, so any feedback is welcome. And also, we have already, it will provide a first fit allocation algorithm, and should be distributed, because I say everything for us has to be distributed, so we want also the algorithm for the allocation to be distributed. Then let's say the most important part that we have today, as said, is the fog infrastructure manager that virtualizes the hardware and provide those primitives to manage this virtualized infrastructure and this, let's say, homogeneous view over this heterogeneous infrastructure. Now we introduce some of the abstraction provided by the theme, which are the resource, the node, the network, the router, sorry, the port, and the fog deployment unit, which is the FDU. For FogOS, a resource is something that can be assigned in either an exclusive or shared manner to an FDU or to something that you can deploy. So a resource can be anything like an FPGA, can be a specific I/O interface, can be some GPIO ports, can be an hardware accelerator, portion of virtual or real CPU, portion of RAM or disk, and so on. So it's something that can be assigned to an FDU. Then we have the node. The node is a location for resources. So a node can be anything that has resources on it, like my laptop, this small, my iPhone, or I don't know, a Raspberry Pi, a very small, let's say, microcontroller like an STM32, because we have a resource on it and you may want to be able to use that. And in order to expose these resources in FogOS, you need either an agent running on the node or a device plugin. We'll see after why you can have one or the other. Because as you can imagine, the agent is a little bit bigger for some sort of devices like microcontrollers, while the device plugin is something that can be very, very, very small, and so can be installed also on these microcontrollers and small devices. Let's say, and the heart of FogOS at the end is the fog deployment unit, which for us is an indivisible unit of deployment, which can be anything for which we have a plugin and which implements our state machine. Why I say it can be anything? Because as we said, we have to interact with this heterogeneity. So we cannot think, okay, I will use container for everything. Well, okay, containers are good if you need to deploy on servers or on devices that are not really constrained. But what if, for instance, I have to deploy something in a robot? I cannot deploy a container in a robot, maybe. Or I can, but then this container cannot interact with the hardware that is on the robot, like the robotic arms and so on. So we think about, okay, we define an abstraction, which is the FDU. We define a state machine. We define a plugin interface. And then if someone wants to implement this plugin to manage something pretty, let's say, strange or complicated, it's up to him. But we provide plugins for managing containers, VMs, native applications, and I think, also ROS2 applications. ROS2 is a robotic framework. And then, of course, between those FDU, you want to create virtual networks. These virtual networks in FogOS can be both level 2 networks, so just Ethernet networks between the FDUs, or can be level 3 networks. To do this, we leverage existing technology like VXLAN, GRE, and so on. So nothing so fancy. But in this case, you have the possibility, for instance, if you think about this is the unified view by FogOS, you deploy your application, then part of your application will be on the things, part on the cloud, part on the edge, and then you can just interconnect them and make them talk. We defined our information model, which is based at the moment on JSON, but we are thinking on moving that probably to YAML because it's more human readable compared to JSON probably. And in this information model, we define the descriptors that you use for the FDU for the entities, but also the information that comes from the node. So the resources that you have on the node, the status of the node and the status of the FDU, and all the resources that are part of the node and of the system. Let's say this is our application stack for FogOS. So if we go bottom up, we have the agent and the plugins, which are more or less at the same level. And they use to communicate, they use YAX. YAX is a distributed key value store that we are trying to put inside the Eclipse edge. I mean, we are trying to open source in the Eclipse Foundation. So we are in discussion with Eclipse in order to have that. And his goal is really to provide location transparent access to the state of the system. So I said it's distributed, and it provides a way to access the state, so there is really no replication. So if you have your, let's say, my FogOS system is composed by my mobile phone, this laptop, and for instance something running, let's say a Raspberry Pi. The state is kept in the device where the agent is running, but everyone can access that state. And then the state of the system is built by the unification of the state of all the devices. And FogOS and YAX helps to do that. YAX is based on a protocol that we are doing, and it's open source. His name is Zeno. And it was designed in order to be, let's say, with a very small overhead. So in order to be capable to run on BLE, because BLE has a very small payload. So in the case Zeno is running on BLE, I think the overhead is just 4 bytes. And that helps if you're going to very small devices, but you think, okay, if I go to big servers, well, I will also take advantages of this because I can send more data. And also Zeno is a peer-to-peer protocol. It can be both broker-based and peer-to-peer. It can be routed. There are Zeno routers, and is used to distribute this state. So at the end, YAX built on top of Zeno. Sorry. From FogOS, you don't see Zeno, but it's there and they'll pass for the distribution of the state. Okay, the agent at the end is a closed loop management for the node, and the plugin just provide the extensible hardware and software architecture. Well, I said that before that in order to have a device be part of the FogOS system, you need an agent or a plugin running on it. Indeed, there are different deployment options for FogOS, where the Z stood for Zeno, I think it was Zeno Broker, and then there is YAX agent and plugin. And so, like in the biggest deployment you can have, you have something like this, which I think is good. It's not using that much memory footprint nor CPU footprint. While if, for instance, you want to target very small devices, like this one, which was an STM32, was this board, a Nucleo from ST, you can use just the plugin for the device, build that on embed, and it will just use 58 kilobytes. In this case, it was of flash memory, because we were not able to check the RAM. And in this sort of deployment, the deployment is a little bit different, but from a user point of view, the user will have the view that this is a complete node. You will not see that one is just a small device with a plugin. When it uses the FogOS API to show the list of the node, it will say, okay, there is this node with this UID. Then when you get the information about that node, you will see that that node is just a microcontroller, but you have it. So you don't have to bother about, I can connect my small devices. And while in the device, for instance, the other deployments, when you don't have the YAX server, this means that the state will not be kept in this node, for instance, but this node, the state of this node will be kept in one of the nodes in which we have the Yax server. So we have some initial numbers that I think comes from last year. We started to do some, because people asking, okay, how this compares to OpenStack? Okay, but how this compares to Kubernetes? So we started to do some measurement, mostly in this case are based on the container deployment, because the VM ones are very big. I mean, if you just take 30 seconds to start something, maybe it's better if you start using containers. So what we have done, we have implemented in fog05 the LXD plugin, which are the Linux containers one, that are a little bit different from the Docker one. And then we implemented a first very basic version of the Docker container for fog05. And then we tried the deployment time. We measured the deployment time, I think it was like 100 times, 250 times the deployment, and then we have done the median. And just to verify if the overhead added by fog05 was affordable or not. Well, I think in this case is affordable. You can also tell me that probably the Docker plugin is not well written because it has more overhead than the LXD one, but it was just to verify that everything was okay. And you can see Kubernetes is a little bit more, takes a little bit more time, but this time becomes tricky when you have like a chain of dependency in your service. And this is like the worst case because you have a service that depends from a service that depends from a service. So we have tried increasing the length and measuring the time. And I mean, fog05 is the blue one, so it's quite good compared to Docker because it didn't add that much, while Kubernetes was exploding. That version of Kubernetes is, I think, is not the last one for sure. So probably we have to redo the measurements also because during that measurement there was no, let's say, single node version of Kubernetes. So you have to install Kubernetes and then just add one node to the controller. While today you can just use mini Kubernetes from Canonical, and so probably it will be different. But also, I mean, Kubernetes is taking more time also because it has all the orchestration on top. It has a lot of containers that do a lot of stuff that we don't do. So it's okay that it is taking more time. That much I'm not sure is okay, but it's taking more time. Then we have some use cases that are mostly coming from our from the project, the European project in which we are participating. We have use case like convergence between the ETSI, MEC, and the NFV. You know what is NFV? NFV stands for Network Function Virtualization. It's something that comes from telco that they don't want to have like the firewall as an hardware device, but as something deployed on a cost-of-the-shelf hardware. So on a server, it's a virtualized, for instance, firewall, a virtualized, I don't know, mobile network core, something like this. And there is a convergence between this let's say, working group, which is now it's becoming a standard, and the MEC, which stays for multi-access edge computing. But this is more, let's say, telco related. It's not very IoT or industrial IoT related. And in that case, we have done, I think it was last year at ICT in Vienna, which is it's a convention organized by the European Commission. And then in that case, we showed the interoperability between fog05 and the orchestrator coming from ETSI. And they were deploying some DNFs packetized as LXD containers and the MEC platform and everything that was from the MEC. Then we had also some very nice demo with fog-assisted robotics. In that case, we were deploying the control logic of the robots and also the application inside the robots. In that case, the robots were running ROS, I guess, ROS1. So the application was not managed as a ROS2 application from the fog05 point of view, but as a native application. And in that case, I think it was pretty nice because you can see that those devices becomes part of the fog infrastructure. You have them. In the case was a use case about having some general purpose robots on a shopping mall that they have different, let's say, capabilities. So you can just deploy the application on that, and the robots will follow the application. This case was a delivery of a goods, but there is in the same demo was also deploying one of the robots to do a cleaning service. The robots was the same. In this case, they were just simulating a cleaning service, but it's nice to see that you have some general purpose robots that in which you can just deploy your application. These two are very, very, let's say, small and constrained devices, are two Lego and XP, and we tested the deployment also on that for the same European project. In this case, the application was pretty stupid, just don't go outside of the line. Also, we had some vehicle to everything demo use case that will be done in Barcelona, I think, by the end of the year or beginning of 2020. It's pretty interesting because in that case, we will deploy application in the lamppost using fog05. So the application will be orchestrated through the orchestrator from Etsy because it's coming from a European project. And then you have this application that will be deployed in 2 different lampposts, and that will be used for vehicle to everything communication. It's something like there will be 2 cars that goes in the road, and then if there is a road hazard, then one application in the car will trigger to the infrastructure, and that this infrastructure will trigger to the other car to say, okay, see, be careful, there is some road hazard on the street, so please be careful. And then we had also a very interesting use case. This is interesting, but more about the heterogeneity, because use case was shown in Mobile World Congress this year, by InterDigital, which is a partner of us in a project. And they were showing the deployment of a VR application. So in that case, you had the client application, which was a Windows machine, but the processing was done by an NVIDIA Tegra device, which is Linux and based on ARM. So that is nice because show the real heterogeneity, and they were just using one API to do everything. So what's next? We hope for the end of the year. We plan to do the first release of the project, because nowadays there are no releases. There is just the repository and the GitHub, and we are pushing a lot of commits each day. And so we updated the website, which is I think is the first step then to go to the release. Then we implement by the end of the year the containerd plugin. Containerd is the one container runtime interface that can be used to deploy Docker containers. As said, we had a very basic Docker plugin, but we said, okay, in that case, you have to use the Docker API and you will have complexity. So we can use containerd that it's used directly by Docker and also now by Kubernetes. So we can avoid to have some layer on top, and we'll just use containerd. Then we plan to integrate with Kubernetes. With Kubernetes integration, I mean, we want to be able that the user can use Kubernetes API in Kubernetes command line interface, for instance, and YAML to deploy application using fog05. In this case, we are not thinking about deploying containers, but what we want to do is mostly having the possibility to add the possibility to Kubernetes to deploy native application or robotic application. So we are working on that, and we are trying to see where we can hook up on Kubernetes to add this possibility. Then we are going through a repository reorganization. We already asked to the master of the Eclipse to create our own organization in order to have different repositories, in order to facilitate also the testing and the deployment for the stuff. And we are working on improving the documentation, which is something usually for open source project, we do a lot of stuff and then the documentation is just at the end. Okay, I think that's all. I think we have 10 minutes, so if you want, I can show you a very small demo in the deployment of a native application in a VM which is running inside my Okay, so I have a lot of terminals over there, as you can see. So in these terminals, I will deploy the portion of fog05. So in this case, over there, I will deploy the Yax server. This one, the agent. This one, the Linux plugin. And this one, well, you can do also using systemd. I'm doing this way because in this way we can see what's going on. And this is the native plugin. Okay, then I have started everything. Yeah, I know. I can try to make it bigger, but then I need 6 terminals. So you have just to trust me that over there you have the Yax server, in this one you have the agent and plugins over there. So then what we have our application defined by fog05, because in this case is this one. Let me make it a little bit bigger. Okay, I'm defining my FDU in this case. This FDU is composed by, these are the requirements for the FDU, and it's a binary application because I'm specifying this portion of the descriptor, this command. I'm also telling it the hypervisor is bare, so there is no hypervisor. It's just something that you need to that can run directly on the node. And in this case, the migration kite is called because you cannot do live migration. You cannot do real live migration with a native application. And then I will use the fog05 Python API to deploy this. Well, in this case, I am just having a dictionary, a list of tuples in which I have the name of the descriptor and the node ID. And then I will just deploy that on the node that is my virtual machine. So, okay. Okay. So I will start the deployment, and you will see, you will say, okay, this is the ID of the things that I am instantiating, and I'm starting something over there. In this case, there are some screens. Where is it? Okay, over there. In this case, we said, okay, the binary is this guy over there. So if we go on this, it's bigger this time. I have something which is called test.sh. And this is the application that I'm deploying using fog05. This application is just starting 4 screens, 3 doing a ping, and the other is starting a very stupid Python application that just prints hello world and the timestamp. So for instance, if we do a screen, okay, minus R, and we take 1, which is PIA, you see that it's running. It's say I'm breathing, I'm breathing hello world, I'm sleeping, and so on. So I add a touch from this, and for instance, if I touch to another one, which can be pinged, okay. Sorry. 1, then it's not more working on the Mac. You see, it's pinging, in this case, the Google DNS. And everything is fine. Then, okay, I want to stop this application. I can just, I will show you first the stop script. The stop script will also use the fog05 API. In this case, we just see the list of the nodes. We'll search for all the FDUs in the nodes, and we'll stop all the FDUs instances running on each node. And so I will do something like this. Stop. You see, okay, I'm stopping something. I'll say there are no more screens because the application was terminated. If you want to see something more interesting from the Python API, so I import. Because these are the API at theme level. This is the VM and the fog. Okay. I don't see the stuff from. Okay. Let's see if this thing is working. No. Yes. Well, there is some probably right. Well, okay. But for instance, if I take the node ID, which should be something like this. Can get information about the node if the end is working. Okay, info, and then just put. You see, I get information about the node. For instance, in this case, the UID, the name, which is the host name, the operating system running on, a list of the CPU. Well, the frequency is 0 in this case because it's a VM, and the link spring is not able to get the real frequency, information about the RAM, the devices, the hardware, the disks, the network devices, and all the devices that I have in this VM. And that's all from me. Well, so, as said by Eclipse, please evaluate the session, and if you have a question, please just ask. So the name of the project is like this, mostly because fog05 was already registered. So we found a way to write OS without writing OS. Well, then there is, after that, we come up also with, let's say, the technological sort of answer to that, which is it has to do also with 5G, and so this is why there is the 5 in the name, but the real answer is that. Well, if you a similar, yes, but it's more like can be done by Kubernetes or Docker Swarm. Because for instance, if you think about OpenStack, you cannot really define connectivity between them, between the VMs. You can do if you use probably OpenStack, the orchestrator of OpenStack it, or if you use some other orchestrators coming from the telco world, like Cloudify or EtsioSM or OPNFV, these sort of things. But from an application point of view, yes, it's more like Kubernetes. So in Kubernetes, you have your YARN file. In your YARN file, you define your connectivity, the port that you want to expose, the pods, the replicas, and all this sort of stuff. That also in our case we want to expose, but that will be in the entity descriptor, so not in the FD1, which is the one that the demo, which was the one with the demo.